Hello, welcome to KiCad tutorial 1.3 part B, where we're going to use the electrical rules checker and re-edit one of the component symbols. One of the symbols that we are going to edit is the symbol of the MOSFET transistor. This series is based on a blog, the particulars of which appears in the description below. The MOSFET transistor, the Si4128 that we drew on the previous video, is this symbol. We can just click on it, and as you can see, this MOSFET has 3 source pins, which are output pins. Now, let's run the electrical rules checker. Let's open a schema again. Okay. To run the electrical rules checker, you click this icon with the red bug on. Click on it. Just to rerun it again, just delete the marker, click run. As you can see, we have 2 warnings and 2 errors. And the 2 errors are the most serious, and the reason why KiCad is complaining, it says that pin 1 is an output of U2 is connected to pin 2, which is an output of U2. And pin 2 is an output of U2 is connected to pin 3, which is also an output of U2. And it is KiCad also uses these arrows. If you click here, it actually there's a little cross that goes to that arrow, and you click here. There's a little this marker goes to this arrow, and this is what KiCad is complaining about. Now, the reason why this MOSFET transistor has multiple source output pins, one can find a discussion if one clicks here. The link to this web page I also put in the discussion below, but it basically has to do with the dissipation of the heat in the MOSFET transistor. This discussion relates to the multiple drain pins, but the same applies to the source pins. It gives a bit of a discussion here, but basically it says that the drain is connected to a large area of the MOSFET transistor, and if you have multiple pins, you have multiple wires that go to those pins, and then the heat, it helps with the conduction of the heat from the transistor out of the transistor into the pins. And the same principle applies to the source pins. That's why a transistor has multiple source pins, so that the heat can heat can be conducted from out the transistor into the source pins and out of the transistor itself, and so it keeps the transistor cool. One must also remember that these MOSFETs, they conduct high currents, and if you have multiple pins, then you lower the electrical resistance, and this facilitates the flow of the current through the MOSFET transistor. Okay, so let's go back. Actually, I want to show you the criteria that KiCad used to generate these errors. If you click on the Options tab, if you look here on the second row, you have an output pin, and corresponding to the input pin here column, you have an output pin row and you have an input pin column. There's a little green box and no error is or warning is generated. If you have a output pin connected to an output pin, it's got this little red box with an E in it, and an error is generated. Now one can quite easily get rid of this by just clicking on this, and then you change the criteria of KiCad. And if you now go back and click run again, you see the errors go away. This is not good practice. It's actually much better to make use of the default settings of KiCad, and when you have an output pin connected to an output pin, for safety reasons, it's better to have an error generated. So because that's a warning, but let's keep it at the default setting of KiCad. So when an output pin is connected to an output pin, an error is generated. Just to illustrate this, let's click run again, and you can see the errors are back. So what is the solution? The solution is we must try and fool KiCad, so to speak, not to generate an error without changing the default error settings of KiCad. And what I propose to do is to change the settings, or rather to change the source pins, to make them different pins. I just want to show you again here. If you change the output pins to passive pins, no error will be generated. As you can see, a passive pin in the case of an input pin, no error is generated. In the case of a passive pin and an output pin, no error is generated. In the case of a passive pin and a bidirectional pin, no error is generated. In the case of a passive pin and a tri-state pin, no error is generated. And if a passive pin is connected to a passive pin, also no error is generated. So what I propose to do is to change two of the source pins to passive pins, and then hopefully no error will be generated. In a schema, select the MOSFET transistor Si4128, right click on it, select properties, go down to edit with library editor, zoom out a bit, centralize it a bit, select the second pin, which is the source pin with an output setting, right click on it, select edit, in electrical type, scroll down to passive, select passive, click OK, select pin 3, right click on it, click edit, in electrical type, scroll down to passive, select passive, click OK. Now click save, click close. Now let's do run the electrical rules checker again. Click on the red bug icon, You can see there, just delete all the markers of the previous run. Click run. As you can see, all the errors are gone, only the warnings remain. Click close. For the moment, we can ignore the warnings. I think this is enough for now. Next time we will assign footprints to the symbols. I do provide all the links in the description below. If you have any questions or suggestions, leave them in the comments below. If you feel this video has helped you, give it a like. If you would like to see more, click the subscribe button. Thank you for watching, and goodbye.